So Purushottam Yadav,
మైక్ ఆఫ్ చేయి
please.
ఆఫ్ చేసాను నేను.
Off చేయలేదు Swami. Off చేయలేదు. I can still hear you. Right. So, okay. So basically, first we have two classes. One is IPv4, total 32 empty slots are there, and IPv6, total 128 slots are there. But before that, let's discuss what is public IP and what is private IP. You remember public IP and private IP we already discussed. I gave an example. Chinna Ganna Bujji is a private IP. Avinash Reddy Tipparthi is a public IP. Right? So, you know, public IP addresses are unique across the globe. So if you are able to access internet from your mobile, there is a public IP address associated with it. Okay, if you are able to access internet from your laptop, so if you open this browser and if you give my IP, here you can see there is a public IP address. So across the globe, no one will have this public IP address. Only this is Naresh IT's public IP address. It is configured to this Wi-Fi router. How many devices connected to that? It is going to get same. Forget about that. Okay, but this public IP address unique across the globe. No other device is going to have this public IP address. So if I commit any mistake, if I did any crime, cybercrime cell directly come here and they can caught me. Why? Because it is unique across the globe, right? Okay, so that is a public IP address. And private IP address, it works only within the network. As I told you, in your home, so your mother or your brother or your father may call you like a Chinna Kanna Bujji, right? So in similar manner, in another family, another guy also may call with the same name. So those names unique within their network. That is a private IP address. Okay. So now this IPv4, total IP addresses, okay. IPv4 total IP address, we are going to get around 4 million IP addresses. Where is that? Yeah, you see this? These many IP addresses we are going to get. So I told you total 32 empty blocks are there. 0 is there and 1 is there. How many ways we can fill up? 2 to the power 32. Those many combination we can fill up. So around 4 million unique IP addresses we are going to get. Okay. So now from 2010 onwards, I'm listening this. IPv4 is full. IPv6 is coming. Still we are using IPv4 only. Some organizations started using IPv6, but here we are going to discuss with IPv4. Okay. So from last 1.5 year onwards, AWS started supporting IPv6. Till that time, only IPv4 available in AWS also. Okay, but now we have IPv4 and IPv6. So our main focus is on IPv4. Okay, in interview also you can mention same, that is 100% acceptable. Okay, so that is IPv4. Now, as I told you, this IPv4 is coming to end. These many IP addresses, like, you know, most of these IP addresses used and or reserved and all. So then what this organization, IANA, ICNN kind of organizations, what they did, they have introduced a new range called IPv6. There, instead of 32 empty blocks, we have 128 empty blocks available. 128. So IPv6 wiki, you go here, you can see here, we have n number of the IP addresses. This is the IP address range and you see, theoretically, it is going to allow 2 to the power 128. So, or approximately 3.4 into 10 to the power 38. The value is, they are not able to write it here. So that's the reason 3.4 into 10 to the power 38 total IP addresses we are going to get. Okay. So that is a IPv4 and IPv6. Now here in IPv4, we are going to get these 4 million IP addresses, right? Okay. all the 4 million IP addresses public IP address or private IP addresses? For easy segregation, what they did is they have segregated into different classes. So class A, class B, class C, class D, and class E. Total 5 classes available. First 3 classes are public usage. A, B, C is public usage. D and E. So D is for R&D purpose. E is for broadcasting purpose. Okay. So you see here, I have written that here. Class D is for broadcasting purpose. Class E is for R&D purpose. Okay. So basically, so the class A range starts from 0 to 126. Including 0, it is 127. Okay. If we calculate from 1, it's going to be, okay, 127, right? If you calculate from 0 to 126, it's going to be total 127. When coming to class B, 128 to 199, 127 is not added here. You see here, 0 to 126 is there. 127 is missing, 128 to 191, 192 to 223, 224 to 239, 242 to 255. But what about 127? 127 is a loop back IP address. You remember local host or loop back IP address. 127 series is a loop back or local host. It points to the same machine. It won't point to any other machine. It points to the same machine. We are going to have an IP address called APIPA IP address, automatic private IP addresses. That also comes to the same class and all. Okay. So here 127 is a loop back. Class A range is 0 to 126. Class B range is 128 to 191. Class C range is 192 to 223. These are public uses. You must remember this. No need to remember class D and E. It's 224 to 239, 240 to 255. Okay. Again, if you're taking class A, 0.0.0.0 to 126.255.255.255. So if you're taking first IP address and all, so it's going to be 1.0.0.0. It starts in this manner. 2.0.0.0. 3.0.0.0. It eventually it comes till 126.255.255.255. Okay. So class A range is 0 to 126. Again, this entire range 0 to 126 is a public IP address except one range. See, public IP address will cost us. You are taking internet for your home, right? You're taking internet for your home. Okay, you're paying monthly some amount. For what you are paying that amount? Not just broadband, not just the bandwidth you are going to get. They are going to allocate to a public IP address also. For that public IP address also you are paying primarily. That public IP address, how much speed you are taking, or fair usage policy like 100 GB or 200 GB download, 500 GB downloads. So that, okay, these 3 things, public IP, how much speed, how much data you can download, these 3 things are involved in your pricing. Every month you are paying internet bill, right? 3 things. So that public IP address comes from one of these ranges only. If you observe here, I have given my IP. So it is showing 183.82.125.5. What range it is? 0 to 126 is class A. 128 to 191 is class B. 192 to 223 is class C. Which range it is? Class B range. So, yes, this Act Broadband is using class B range for this Naresh IT Wi-Fi network. They are giving class B range. Okay. Similar way, you take out your mobile or you you open your laptop, give my IP, it will show some IP. It will definitely show some IP that falls into one of these categories. And you're paying for it. Okay. Clear so far? Total 3 ranges for public usage. Again, let's take a scenario. I have 5 desktops here. I want to enable communication between all the 5 desktops. 5 laptops or 5 desktops, I want to enable communication. Just internal communication. I don't need internet. I don't need internet. So now my first question, can a computer communicate with another computer without IP address? IP address is like a name. IP address is like a name. If I want to call you, you definitely need to have some unique thing, right? So the uniqueness comes with an IP address within the network. Okay, again, for enabling communication, just internal communication, do I need to purchase by a public IP address and do I need to configure? No. No, right? So for internal communication, we can use private IP addresses, not the public IP addresses. Private IP addresses are free. Private IP addresses are free. It won't cost us anything. We can use within the network or internally. For internal communication, it works. Okay. How we can see private IP address? You just open the command prompt, you give ipconfig. In your Windows laptop, you gave ipconfig command, it shows you IP address information. So if as I'm using Linux flavor, I have given ifconfig. You see here, so 127 is a loopback IP address. Okay, so somewhere here, I will get an IP address 192.168.42.110 is my IP address. This device, see, there is a difference. This is 192 series. This is 193 series. Both allocated to same laptop. But remember, this is a private IP address. This is a public IP address. You might get a doubt. Hey, Avinash, how you are saying this is a public and private? So whatever the 3 classes we have here, from every class, there is a range reserved for internal usage. There is a range reserved for internal usage. For class A, 10 series, 10.0.0.0 to 10.255.255.255 is reserved for private IP address range. So without paying anything, you can use that IP address range. For internal communications, you can use it. Okay. Whenever you're taking class B, 172.16.255.0.0 to 172.31.255.255 is a range reserved for class B. If you want to use it, you go and use it. No need to pay anything. No commitment with anyone. Okay. You can use it for internal communication. When coming to class C, 192.168.0.0 to 192.168.255.255 is a range for class C. That's the reason you see here 192.168. So whatever the laptop or device connected to this Wi-Fi network, they will get an IP address 192.168 series. It's free. My laptop can connect it to my phone if both are connected to a Wi-Fi. You know, in your home, if your TV and your mobile phone connected to Wi-Fi, you can do screencasting. How that is happening? How the screencasting is happening? Or you configure any public IP address and all? Not really required. By using both connected to same router, it is using private IP address for this communication. Okay. So that is a simple logic. So 3 ranges you must remember. 10 series, 172.16 to 31 and 192.168 range. These 3 you must remember. Why? Because whenever we want to create a VPC, the first thing we are going to choose one of these ranges only. Okay. So clear with public IP address and private IP address so far? Any question so far for me? Is it clear? Any question so far? So key points so far. We have IPv4 and IPv6. IPv4 is a 32-bit, 2 to the power 32. IPv6 is a 128-bit, 2 to the power 128. Okay, that is the first thing. And we have different classes. Class A, 0 to 126. Class B, 128 to 191. Class C, 192 to 223. Remember this. These are all public series. But for internal usage, we have a specific range from each class. Okay. So from class A, the range is 10 dot. From class B, the range is 172.16 to 31. From class C, the range is 190 to 168. Okay. This is what we discussed so far. Okay. So now, without paying anything, I can enable communication between all my laptops or desktops. Even once you go to your home, you just give a try. You open a browser, give my IP, it will show one IP. You open command prompt, give IP config, it will show another IP. Okay. So just give a try. Both are not going to be same. It's going to be different. All right. Okay. So that is a public IP and private IP address mechanism. Now, let's discuss about network and host. What is a network? What is a network? Is Facebook a network? Is LinkedIn a network? How big is your network is? How big is your network is? Hey, I know KTR, I know KCR. Huh? That much big network I have. What are you talking? Right. So whenever some fight happened, and that guy will tell Jagan. Right. So the network. So basically, the resources which can communicate. This classroom, I can call it as a network. This class is a network. Okay. So you can communicate any of the member in this classroom. And we have a communication platform like a Slack, or you can communicate here itself. Right. So we can call this class as a network. How many hosts are there in this network? Host is nothing but member. 120 members are there in this network. 120 hosts. So how many Facebook accounts you have? How many you have? One. Okay. How many friends you have in that Facebook? 1.2 million. Okay. Okay. So 1200. All right. So you have only one Facebook account. Technically, we can call that as a network. Within that, how many friends you have? Each friend is equivalent to one host. If you have multiple networks, multiple Facebook accounts, yeah, we can call it as a multiple networks. One account like 1200, another account like 500 or 600. All right. So network is like a group of interconnected resources that can communicate each other. One resource can communicate another resource if it is within the network. Okay. So now, how many devices we have? So that is a host. So similar way, here in VPC also. VPC is a network. How many instances you want to add to that VPC? That is a host. Okay. So based on these classes, we have different network count and host count. So if you are taking class A IP address, the mechanism is, okay, I'll do new tab. So if you are taking class A, so the mechanism is first, basically IP address have 4 parts. First part represents the network, remaining part represents the host. When coming to class B, first two parts represents the network, remaining two parts represents the host. When coming to class C, first three parts represents the host, last part represents the first three network, last part represent net host. Okay. So now, how many networks we are going to get, how many hosts we can add, and what is the logic behind it, we will discuss now. Okay. So I told you in class A, what is the range? 0 to 126. But private IP address range I'm going to take now. One IP address range I'm going to take. So 10.0.0.0. So now 10 dot is one network. If I don't want to take 10 dot, I can take 1 dot. End of the day, first one represents the network. So can I say this as a network? These remaining are hosts. Now, how many hosts I can add here? Let's do that. 1 dot, 1 dot 0 dot 0, 1 dot 2 dot 0 dot 0, 1 dot 3 dot 0 dot 0, till when? 1 dot 255 dot 0 dot 0. Is it full? Now, 1 dot, okay, 1 dot 1 dot 0, 1 dot 1 dot 2 dot 0. Fine, it is also full. So then we can take 1 dot 2 dot 1 dot 3 dot 1 dot 4 dot 1 dot 5 dot. So how many devices we can add to one single network? You see, there is no change in the first part. Am I changing this? But only remaining three changing. So it is increasing. Till when we will get? We will get 126.255.255.255 till this. So you just imagine how many devices we can add to one single network. So if you are using class A IP address, we can add 16 million hosts for each network. The example I have taken here, just one, right? So within this one itself, I can add 16 million hosts into this network. The logic is simple. So if this 1.255.255 it is full, 1.255.255 is full, I can simply take 2 dot 2.0.0.0 to 2.255.255.255. This is also full. I can take 3.0.0.0, 3.1.0.0, 3.2.0.0. Similar manner again till when? So 3.255.255.255. So end of the day, we are going to get 16 million combinations. You got the logic? Everyone. This is important for me. Okay. So this is the class A logic. When coming to class B, so as I told you, first two represents the network, remaining two represents the host. So let's take one range as an example. So I'm going to take 172.16.0.0 as an example. First two is a network. So within this network, how many hosts I can add? 172.16 is fixed. I can give 0.0. Okay. So then I can give 1.0. I can give 2.0. I can give 3.0. 4.0. So till when? 255.0. Fine, this is full. Then what I can do? 172.16.1.1, 1.2, 1.3, 1.4, 1.5. Till when? 1.255. This is completed. Then what I can do? 172.168, 16 dot. So then 2 dot. So we can add, like, here the logic is very simple. Network is fixed. Here 0 to 255 combinations we are going to get. Dot 0 to 255 combinations we are going to get. When coming to class C, we are going to get a lot of network, But what is the host count? It's just 0 to 255. So only 256 hosts you can add. But how many networks you can create? Lot. Okay. So here you observe network, host. So we can create 16,000 networks. How we can create 16,000 networks? You remember class B is from 128 to 191. So 128.0 is one network. 128.1 is network. 128. Till 255 is one network. 129, 130, 131 till 191. That's the reason we can have 16,000 network and each network supports 65,000 hosts. When coming to class C, first 3 represents the network. Last one represents the host. So generally 0 to 255 only. So 2 million networks we can create. But each network can have only 256 hosts. In your home Wi-Fi, how many devices you are going to add? Are you going to add more than 250 devices? No, right? That's the reason most of the times in our home network or in home Wi-Fi's, this class C is configured. Remember, by using these classes or IP address ranges, you no need to pay anything to anyone. That's the reason we use it for internally. Okay. So this is a class A, B, and C, its limitations or ranges. Okay. Any questions for now? Any questions as of now?
Avinash,
So network, one second. Network is like, for example, as I told you, this classroom is a network. Okay. So for this entire classroom, there is a capacity defined, right? In this classroom, only 60 members can sit. That is a range of this class. That is a limitation of this class. So similar way, whatever class you are taking, for example, you are taking class C. You are taking class C, but you are trying to add 300 devices to that network. Will it support? No. So you are taking 60 members classroom and you are sending 100 members. What happened? It won't support, right? So network is this classroom. Okay. Each and every candidate is a host. That host will have IP address. Network will have IP range. From Z, see, the logic is very simple. Whenever you go to cinema hall, okay, so this is a row. Within a row, we have 0 to 20 members this side and 21 to 40 members this side. First of all, that is a row. Let's assume that as a network. So 20 members here and 20 members here. So each seat is allocated to only one guy, right? So that is an IP address. 1 is an IP address. 2 is an IP address. So the row, you can call it as a network. Okay. Yeah. So that is a IP address and network. Yeah. Someone asking something from online. Yeah. Please go ahead with your question.
Yeah.
So the range is completely different between IPv4 and IPv6. Here we are viewing like a 10, 7, 192, 255 and all. But there the IPv6 range looks completely different. It will be in this manner: 2001, B, A, 73. Your IP address, IPv6 looks in this manner. End of the day, it again converted to zeros and ones, and your system is going to understand that. Okay. So now let's discuss about subnetting. Okay, this concept, if you understand or not, doesn't matter to me. First thing, this is important for me. Okay, remembering these 3 ranges important for me. And whatever the topic we are going to discuss now, that is important for me again. So whether you remember this logic and all, doesn't matter to me. Okay. So now, when coming to this subnetting, so you might see in some IP address, like, next to IP address class 32, slash 24, slash 16, you might see, you might use a step of IP addresses. We are going to discuss what is that slash 32, what is a slash 30 or 24 or slash 16 or slash 8. Okay. So for that, let's take a very simple example. So as you know, the computers can understand only zeros and ones. Okay. Now, 32 chairs are there. Here in diagram, I'm going to take only 2 or 3. Let's assume 32 empty blocks are there. The 0 and 1 already occupied 32 slots. How many outputs we are going to get? 1. The logic is very simple. Total 5 members is sitting in this row. Only 5 chairs are available. If I want, I can jumble here and there. But how many outputs I am going to get? Only 1. End of the day, no one, I cannot accommodate anyone here. So only 1 output I am going to get. For example, okay, 0 and 1 is waiting here. And 1 empty chair is there. 0 and 1 is waiting here. And these 2 already full. These 2 already full. Only 1 empty chair is there. How many ways I can accommodate or shuffle here? I can ask 0 to sit here. That is one option. Or I can ask 1 to sit here. That is another option. So how many ways? 2 ways. Okay. So for example, instead of only 1, 2 empty slots are there. Here a lot of zeros and a lot of ones, not just 1, 0 and 1. Lot of zeros are there, lot of ones are there. Now, out of 32, okay, 30 slots are full. 2 slots are empty. Now, how many ways I can, okay, add here? 2 ways? 4 ways? 4 ways. So I can ask both zeros to sit here. I can ask 0 to sit here and 1 to sit here. Or I can ask 1 to sit here and 0 to sit here. And I can ask both ones to sit here. Got the logic? So if you have only 1 empty slot, okay, I can ask 1 to sit here or 0 to sit here. If everything is full, I cannot do anything. If everything is full, I cannot do anything. Again, the logic is very simple, guys. Don't make it complex. Okay. So you have 10 chairs. Okay. All 10 of your guests are occupied, that chairs. A new guest came. What you will do? So you need to look for new chair, but you don't have. So do you have any option? No option. So only one logic is there. They already fill up. Okay, that is the first example. Now, total 10 chairs are there. 9 guests already sitting there. 1 chair is there. And 1 guy called 0 came and 1 guy called 1 came. Now, how many ways you can add to them? Either you can ask 1 to sit there or you can ask 2 to sit there. So, only 1 guy you can accommodate. Okay, only 1 guy you can accommodate. That is the logic. Now, okay, total 10 members, 2 empty chairs are there. 2 empty chairs are there, 8 already occupied. Some guys came 0 and some guys came 1. Now, you can ask, okay, you 2 come and sit. That is 1. So, you are asking both zeros to sit here, or 0 or 1, or 1 or 0, or 1 or 1. So, how many ways? 4 ways. Now, 3 empty slots are there. 3 empty slots are there. How many ways we can fill up? 6. Now, the logic is very simple. 2 to the power, how many empty? So, initially, nothing available. So, 0. So, what is 2 to the power 0? 1. If all 10 out of 10 is filled up, 1. So, if 1 empty slot is there, so 0 and 1 both are waiting, 2 to the power 1. So, 2 ways you can. If 2 empty slots are there, how many guys are waiting? 2. So 2 to the power 2. If 3 empty slots are there, 2 guys are waiting, 2 to the power 3. So I will show you the logic. 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1. Got it? So how many ways? 8 ways. 8 ways. The logic is very simple. How many empty slots are there? Keep that number. Total 3 empty slots are there. How many guys are waiting? Zeros and ones. So 2. So then give 2 to the power 3. That is the output. What if I have 8 empty slots? What is the logic now? If I have 8 empty slots, what is the logic? 2 to the power 8. If I have 16 empty slots, if I have 8 empty slots, okay, 2 to the power 8. If I have 32 empty slots, 2 to the power 32. So that is what IPv4 range is. If all 16 slots are full, 4 million. If 2 to the power 16, okay, only 16 slots are empty. So then 65,536 IP address we are going to get. So that is a logic. Got it? Okay. So now, whenever you see any IP address range 192.168.100.1/32. Okay. So this 32 represents already filled count. So total, how many we have? Total, how many slots we have in IPv4? 32 slots. And this IP address is saying out of 32, all 32 is full. 32 minus 32, what is the output? 0. So then we have 0 and 1, both are waiting. So then you can give 2 to the power 0. What is the output? Anything power to 0? 0 or 1? 1. Anything power 0 is 1. Don't confuse me. Okay. So total 32 empty slots, 32 slots are there, and you have seen some IP address 192.168.0.0 class 30 this time. So that means total 32 slots are there. This class 30 means 30 is already full. 30 is already full. So 32 minus 30, that tells us how many empty slots. How many empty slots? 2. So 0 and 1 is waiting. So what is the output? 2 to the power 2, that output is 4. Now, you have seen some IP address in similar manner, but it is like a /24. Now, total 32. Here, this /24 is saying 24 is already full. This is going to be fixed always. Why? Because we are working with IPv4. So 32 is always 32. Okay, this representing how many empty slots are there out of 32. How many already occupied? It is saying that out of 32, 32 is already occupied. Out of 32, 30 is occupied here. Out of 32, 24 is occupied. So now I need how many empty slots are there? That calculation. So 32 minus 24. So then what is the output? 8. What is the 2 to the power 8? 256. 256. So if you want, you do calculation. 2 into 2 into 2 into 2. Okay. So then you will get 256. Right. So now you have seen some IP address in this manner. Now, tell me the calculation. Total slots are 32. The IP address is saying 16 already full. Then how many empty? 16 is empty. So then 2 to the power 16 IP addresses we are going to get. So that means 65,536 is the value. Okay. So if you found any IP address with this 192. class 28. What exactly that means? Total 32. 28 is already full. So that means how many empty? 4 empty. So then 2 to the power 4. So then how many IP address we are going to get? 16. Okay. Right. So total 16. So basically, whenever you are creating a VPC, AWS required minimum CIDR range as class 28. It supports minimum CIDR range as class 28, maximum class 16. Okay. So that means you can create a VPC. You can create a VPC with slash 28. That is a minimum. Whenever you create a VPC with slash 28, how many instances you can launch? Just 11 instances. Here it is showing 16 and Avinash is saying 11. So basically, AWS reserves 5 IP addresses. AWS reserves 5 IP addresses. Okay. So why that 5 IP addresses? 2 is general. You take any network, not only AWS, if you take any network, 2 is reserved. Okay. So those 2, one is for network ID. That is a first IP in the range. And second one is broadcast ID. Okay. Among these two for network ID and for broadcast ID. The broadcast ID is going to be last IP. First IP and last IP we cannot use. Even in your home also, you try to observe your router IP address. It's not going to be end with 0. It's going to be end with 1. And broadcasting IP address is the last one, 255 is a broadcasting IP address. Okay. These two, not only in AWS, anywhere you cannot use. That is the first thing. When coming to AWS, 2 IPs, AWS reserves for DNS purpose. AWS use 2 IP address for DNS servers. Okay. And 1 is for future usage. 1 is for future use. Okay. So this in future, if AWS introduced any new component, so they definitely require 1 IP address, right? For that future requirement, they reserve 1. So now when come to this is the IP available IP address, and how many IP address we are going to get, this count is here. But the usable IP address -5 is a usable IP addresses. -5. So usable IP addresses. Okay. So this is a mechanism. So whenever you see any IP address with /16, /24, /30, /28, so can you calculate that mechanism? Any questions now? You got this concept? This is important. As I told you that private IP address is important. Next, this is important.
So, Avinash, so we know how many IPs are available, but how to get the IPs?
So how many available, how to get it, we will discuss. Yeah.
Okay.
So again, so to get these IP address, for example, I want to get I want to allocate 250 IP address for my VPC. The first thing what you need to do is you need to choose one of the IP classes. That 10 series, 172 to 16 to 31, 192 series are there, right? You first need to select one of the range, then /16, /32, /30. So based on the subnet you are adding, those many IPs you are going to get. So I personally prefer one website that is a visual subnet calculator. Okay. So go to this Google, just give visual subnet calculator. So here is the website davidc.net. So go to this website. So I told you, whenever we are creating VPC, we are allowed to use three ranges: 10, 172, 192. So you tell me which range you want me to pick. A, B, or C?
170.
B? Okay, let's go with the 172. I'm taking 172.16.0.0. Now, this is going to be my entire VPC IP range. Now, what is this? How many IP address? How many instances you want me to launch in this VPC? Just give me a number. How many instances you want me to launch?
10.
2.
4, 10. That's it. Okay, I expected big numbers. Okay, so I can give /28 here, then click on update. Now you see how many. So basically /28 will give 16 IP addresses. So this website is not dedicated for AWS. So it do only -2 calculation. So you need to do -3 calculation. Now what happened? 11 hosts. When I'm creating a VPC, I can give this range. I can give this range for my VPC. That means I can launch 11 EC2 instances in that VPC. Now, give me some big number. How many you want me to launch? 10,000? Okay, that's very good number. So now I'm going to take, okay, if I take /16, it's going to be take 65,000. If I take /17, half of it. I'm going to take /18, then click on update. So you see here, 16,382 IP address I'm going to get when I'm using /18. Okay, let's take /19. Let's see how many we will get. So whenever we are using /19, 8,000 only we are getting. So as you mentioned 10,000, so which subnet I need to use? 18 subnet I need to use. Of course, some IP addresses reserved or empty, that is okay. Okay, so the first question, whenever you are in client discussion or any project onboarding discussions, you know what is the first question we are going to ask? How big network you required? How big network you required? How many instances you are going to launch? Okay, right? So are you going to add any more instances in future? So have you considered your future requirements while giving that number? These are the first questions we will ask. I have even a document, I'll show you that. A project begin document. This is a real document, guys. See, the first, we prepared the questionnaire. What is the preferred CIDR range for these servers? CIDR is nothing but the one we are discussing. What range you want me to go with? So how many servers you are going to? Okay, so when we are planning for development, when we are planning for testing, when we are planning for production. So if we want to contact, so these all questionnaire we are going to share it to the client, and that guy need to come up with all his answers. If he have any doubt, he will come back and he will ask us, who is the project owner? Who is the project lead? Okay, so even networking team information also. You see here, what port we want to open to where we want to open. What are the ports we want to open in security group also, we will get a confirmation from there. Okay, so these zeros I modified as it contains some sensitive information. Generally port number 22, we don't make it open for everyone. Okay, so I should not show the client information, right? So that's the reason I removed it. So we are going to give how many connectivity options are there, what are the ways we have, right? So the milestones, when we are planning at what stage. So who is responsible for like, the networking team, if we have any doubt, whom we need to contact, the name, phone number, email address. So first we are going to prepare such type of project begin documents. So then we will start creating VPC. Okay. So the first question, how big VPC they required? So depend on this, depend on his answer, we are going to choose the required subnet. Okay. So you got the logic? Is that answers your question? Any questions so far?
Hi, sir.
Yes, please.
If any issues happen within the organization, like any host are destroyed, like that, how they can track through IP address, sir? I couldn't don't know. Previous 2 days back, it is happened in organization. So they track the person through IP address. How it could be? They will check like that.
Okay, if something happened, if someone did something, how they can track by using IP address?
Yeah,
So,
it is completely removed from the monitoring those hosts, all the things. So they track the person through IP address. How they will check, sir?
So first thing, generally, forget about AWS. As for your question, so we are going to have the resources. So end of the day, if you want to do something in your organization, you need to sit a device which is connected to your organization network. Okay, and he need to log in first,
Okay.
and to remove that or to add that from monitoring and all, he need to authenticate. So here multiple levels are logging. First of all, to remove that, he need to log into that monitoring site, whatever application you are using. So he's logging to that website, then only he can remove. Their logs are there. And even within your network, your firewall is there that captures every single thing. If you are pinging google.com, that captures. Okay. If you're accessing google.com, that captures. For example, you try to attach your resume over your corporate email address, that will caught you. They will caught you and they will ask an explanation. And also, if you try to upload something or if you try to upload something to GitHub, they will caught you. Why? Because they will run some clients in your local laptop. There is a firewall. Whatever the traffic going out or coming into the network, that firewall will do that. And also at application level also. So to remove that server, he need to authenticate. That also enable with the logging. So by looking into that log, so we can say, okay, this user logged in from this device. So how we can say with the IP address. Within the network, IP address is unique.
Yes.
Within the network, IP address is unique, right? If I have 192.168.100.10, no one will have 100.10 in this network. So they can easily say, okay, 100.10 guy did this. So then we can go to DHCP server, to which device this IP address is allocated. To IP address allocation, there is a server called DHCP. So generally in our organization, we are going to have hundreds of the devices, right?
Yeah.
So are we going to sit on each and every device and are we going to configure IP address?
No.
No. So for that, we depend on another server called DHCP, Dynamic Host Configuration Protocol. So whatever the device connected to the network, the DHCP server will automatically allocate an IP address. And that IP address lease duration is 72 hours. After that, it may continue same or different IP address. So, but during that period, when it is activated, which user logged into that IP address device? So simply we can caught him. So that's not at all a big thing. Okay.
Okay, sir. Thank you.
So yeah, remember just play around with this visual subnet calculator. Okay. And remember that all three private IP address ranges, that is must. Remembering private ranges is must. Okay, that is the first thing. And this calculation, class 16, what exactly it means, class 24, what exactly it means, that we will discuss. Okay. So one small thing before closing it. So as I told you, this is for entire VPC. This is for entire VPC. And we are going to get 16,000 IP address. So do I really want to allocate all 16,000 IP address to only one subnet? See, one subnet never satisfies our requirement. Okay, today at starting of the session, I given that example, right? The shop and all. Okay, some need to public facing, some medium, some private or secured. Okay, so it definitely don't satisfy your requirement. You need to create multiple subnets. So in that scenario, so what we can do is we can divide this. You make 4 parts, you make 6 parts. So what you can do this as a subnet 1, you can do this as a subnet 2. So this is a range. Subnet 1 range, subnet 2 range, subnet 3 range, subnet 4 range. Okay. So the logic is very simple, guys. Again, I'll give a very simple example for this. So, one father is there. He have 1 crore property. Okay, let's take 5 crores. Right. He have like, 5 kids. Every kid is going to get 1 crore. Right. So that is one scenario. So he have 5 crores. He have 5 kids. But is it okay if you are giving all 5 crores to only child 1? Another guys don't accept, right? Okay. So similar way, this is like a father. He is going to get 16,000 IP addresses. Now I want to create 4 subnets. Okay. So I can go and divide this IP address into 4 parts. Then every range is going to get 4,000 IP addresses. This is okay. But this father have a thought to, get another son. Does anything left for future use? No, right? So generally, whenever we are finalizing this network configuration, we will keep some things in mind. First of all, what is your requirement? You ask for 10,000 and I have taken a 16,000 range. The reason 10,000 I can use now, remaining 16,000 I can use it for future use. How we can use it? So divide this 16,000 into multiple parts. You see? Okay, I can create one subnet with this, another subnet with this, one more subnet with this, one more subnet. In every subnet, I can launch 2,000 instances. So this is the VPC range. These are the subnet ranges we are going to configure for our public subnets and private subnets. Tomorrow we will do that. I just want to give a basic introduction to this. So you give IP address here, click on update and just try to divide it. You just try to do these calculations. Okay, you will get it. So tomorrow we will configure it. So today, no VPC thing, nothing. We just discussed about IP address basics and network basics. So now it's your turn to remember the 3 ranges and understanding what is slash 32, what is slash 31. Okay. So yeah, any questions before closing the session? IPv4 and IPv6, that's not part of our course. So IPv6 is a bit complex. So that's the reason we are not discussing here. And even in my project also, we are not using. So you can depend on YouTube. I can share some videos if you really want to go through IPv6. Okay. There is a dedicated course available for IPv6. That was huge content it is. No, you mentioned, okay, you are using IPv4. You mentioned in your current project, you are using IPv4. So that is very acceptable. Okay, so if it is in 192, if it is like, if you have any A, B, C in that IP address, that is IPv6. If you have, show me the question or else. So yes. So the logic is very simple. You see that IPv4 have like, in this manner. It have only 4 parts and every part is going to be like, it's numeric and its highest is 125, 255. But you see here, IPv6, it's a 9 parts. So it's a alphanumeric and that too, you won't get like a 255 kind of things. So by looking into, you can say whether it is IPv4 or IPv6. Yeah. 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 Thanks. Yeah. All right. Any other questions? No? Good with this concept, right? Spend some time and try to understand this. So tomorrow we will start with our VPC. Okay? Yeah. See you again tomorrow, guys. Thank you.